Okay, so Rolle's theorem is an existence theorem, which basically just says something exists. So Rolle's theorem says let f of x be continuous on the closed interval, so we know that we're going from a solid point to a solid point, and we're going to have to fill in every point in between, and differentiable on the open interval from a to b. So you'll notice it's open here. And I always have students ask me, well, why is it closed here? Why is it open here? Well, remember that differentiable means you're able to take a derivative. A derivative is a slope. So, and it's a slope, and more importantly, it's a limit, which means for the limit to exist, for the derivative to exist, to be differentiable, the slope from the left has to match the slope from the right at every single point. Well, if you have an actual endpoint at A, there is no slope from the left coming in, and at B there is no slope from the right coming in. So you can't be differentiable on the endpoints, but you can be differentiable up to the endpoints. So that's the difference between continuous on this, which means we are going to have solid points here, no open circles, but differentiable on the open interval. Okay, then it says if f of a equals f of b. So that's the height at a and the height at b are the same. It doesn't matter where they are. They could both be 0. They could both be down here, up higher. It truly doesn't matter. But the endpoints of your interval have the same height. Then there exists one number c, and this is an x value, in the interval from a to b. So there's some c in here. And again, I said it's an existence theorem. A value of c exists such that the derivative at c equals 0. Now remember the slope. The derivative is your slope of a tangent line. So the question is, can I draw something that's continuous, so I can't pick up my pen? It's differentiable, so I can't draw any cusps, and not get a slope of 0. That's really hard. If I go up, eventually I'm going to have to come back down. And what I just created was a spot right here, a relative max, where the slope is 0. If I go down, I'm going to have to come back up. So I have a relative min over here. If I go straight across, well, c could be any point in here because a horizontal line always has a slope of 0. So if I went up and then back down, this would be my c, right there. If I went down then back up like this would be my c. The next thing to notice it says is at least 1. There could be more than 1 because I could go up, come down, go up, come down. Now I've got 1, 2, 3 places. A slope of 0, a slope of 0, a slope of 0. But this just says there will be at least 1. So Rolle's theorem is actually just a particular case, a special case of the mean value theorem. So the mean value theorem is the one that students really need to know. So the mean value theorem says if f of x is continuous on the closed interval and differentiable on the open interval, so it's starting off the same as Rolle's, then there exists a number c in the interval, so it's still going, such that, and then this looks a little bit different. Instead of saying f prime of c equals 0, we have f prime of c equals f of b minus f of a divided by the quantity b minus a. And what this is, if you take a look at your points, a and b, your endpoints, when the x is your a, your height is f of a. When x is b, your height is f of b. And you take a look at this formula, you have f of b minus f of a over b minus a. This is just your slope formula. So it's the slope between the endpoints. And it's an actual, like, real Algebra 1 slope. This is the slope of a tangent line. This is the slope of a secant line. So what this is saying is that if you have some function, and let's say an endpoint's here, an endpoint's here, and we draw a function that's a nice smooth curve, it's continuous, can't pick up my pen, no cusps. I draw something out like this, who knows what it is, and then I look at the slope of my secant line between f of a and f of b. So we'll call this a, this is our f of a, this could be b, which would make this our f of b. The slope of this dotted line would be this value right here, the slope of our secant line. This theorem says that there exists a c, some x value in here, where the slope of the tangent line matches this slope, which if you look at it, you're going along, my tangent lines are steeper, steeper, steeper. In fact, somewhere like right around in here, if I draw a tangent line, I'm going to get the same slope. And in this case, I think it's going to happen more than once. But the mean value theorem says at least once. And as I said a second ago, rolls is a special case because if you look at your endpoints for rolls, they have to be the same height, which means the slope of the secant line, the slope between the 2 points, is 0. So rolls says somewhere in between, you're going to get a slope of 0. So it's just a special case of the mean value theorem. Now again, these are existence theorems, so sometimes you'll be asked to use them to find, like let's say you can find the value of C, but really they're more often used in proofs of other things.